This thermal imaging footage isolates the physical flaw at the center of modern data architecture, the thermodynamic paradox of compute. The industry consumes vast amounts of electrical grid power to run compute cycles, and the direct physical byproduct of that work is intense thermal exhaust. To prevent the hardware from melting down, operators must then buy even more electrical grid energy to run massive HVAC systems just to pump that heat outside. A circular energy architecture captures that thermal output, routing the heat directly into productive industrial or agricultural use. Solving the thermodynamic equation of an AI node allows an operator to eliminate the two greatest costs of data center operations: external power for compute and redundant energy for cooling. The Green Edge Sovereign AI Pilot is a joint venture located in the diplomatic zone of Gigiri, Nairobi. This image represents the conceptual framework of the site, synthesizing rigid silicon compute hardware with natural, organic systems. Instead of laying down another concrete industrial warehouse, this facility takes a heritage ruin and transforms it into what the architects call a living machine. This blueprint shows the physical scale of the project, a constrained 184 square meter micro-facility. The footprint is divided into 4 functional spaces: Zone A for energy harvest, Zone B acting as a greenhouse, Zone C housing the compute core, and Zone D for the mechanical plant. The strict engineering objective here is to build a Tier 1 high-performance compute node that runs with zero grid energy reliance and zero cooling costs. The result is a 184 square meter footprint that functions as a completely independent, closed-loop organism. At the center of the footprint is Zone C, an 8 square meter glass-walled server vault. This enclosed space contains a liquid-ready supermicro chassis loaded with 4 Nvidia H100 GPUs. This diagram shows how multi-instance GPU technology maximizes the utility of that dense hardware. The 4 physical processors are digitally sliced into 28 independent virtual instances. During daytime hours, those instances are allocated to high concurrency tasks, supporting roughly 300 simultaneous users for educational programming and VR gallery tours. When the shift changes to night, the throughput redirects entirely to commercial export, crunching batch processing workloads to render thousands of 4K cinema-quality frames and mint digital assets. By maintaining this continuous 24-hour cycle on self-generated power, the facility manufactures premium digital goods at near-zero marginal cost. The raw supercomputing capacity is fractured into precise fractions, allowing a single small rack to service distinctly different markets simultaneously. To power this compute core without incurring grid costs, the facility relies on Zone A, an energy harvesting canopy covering 120 square meters of the roof space. This canopy consists of a 40-kilowatt Jinko Tiger Neo solar array. As shown in the schematic, the solar energy routes down into Zone D, a utility closet, where it is banked in an 80-kilowatt-hour Tesla Powerwall 3 system, officially severing the facility from the municipal grid. Severing the connection to the local power grid is an absolute requirement for the site's operation. Operating entirely off-grid is an engineering prerequisite for maintaining Tier 1 compute status, ensuring the hardware never experiences a voltage drop. Independent power generation insulates the servers from local grid instability and provides the foundation for strict data sovereignty. The remaining mechanical hurdle is extracting the intense heat generated by the 4 H100s without resorting to grid-powered air conditioning. This diagram illustrates direct liquid cooling. Coolant lines physically attach to the processor nodes, absorbing thermal energy directly from the silicon and turning hot as they exit the chassis. Instead of venting this hot liquid into the atmosphere, pumps push it out of the secure server vault. The schematic shows those red lines routing directly into Zone B, a 50 square meter luxury glass greenhouse, where the heat radiates outward into the enclosed space. The server exhaust maintains a constant tropical climate inside the glass room, creating optimal conditions for cultivating high-value crops like vanilla and orchids. This closed loop completely eliminates the financial burden of cooling the servers, replacing a pure expense with a profitable agricultural yield. Traditional hyperscale data centers are massive, highly visible concrete targets with loud industrial ventilation. The Green Edge module produces zero noise and no visible exhaust. By removing the acoustic and atmospheric friction that typically complicates urban infrastructure projects, these modules are significantly easier to integrate into high-value commercial zones. This map illustrates the camouflage doctrine. Instead of concentrating risk in one massive, easily identifiable facility, the compute capacity is divided into 100 small hidden nodes across a city. These distinct modules can be installed directly inside existing real estate that requires constant thermal energy, like the mechanical rooms heating hotel swimming pools or hospital laundry systems. A distributed network of 100 anonymous $1 million installations is structurally harder to map, attack, or compromise than a single fenced-in $100 million bunker. By designing infrastructure that looks entirely mundane to a casual observer, the facility achieves a superior physical security posture through invisibility. The thermodynamic efficiency of this design creates a distinct financial leverage point when evaluated against enterprise banking metrics. This side-by-side graphic compares capital outlay versus asset value. Hardware and construction cost roughly $385,000, but the infrastructure and land valuation reaches $2.8 million. This is driven by Gigiri's prime real estate and a sovereignty premium for unique security and compliance. Safaricom can deploy this exact pilot as a physical showroom to execute a Trojan horse strategy, pitching identical sovereign vaults to Tier 1 financial institutions. The proposition for a major bank is straightforward. Stop renting vulnerable space in a centralized cloud and instead retain absolute legal ownership of the land, the power supply, and the silicon itself. Because the module is pre-certified as net zero, any institution that buys one instantly deducts those operational emissions from their Scope 3 reporting. The optimal model for secure enterprise compute relies on replacing the massive centralized data warehouse with a decentralized, thermally balanced machine.